Hello everybody. This video is on function or functional notation. Both are correct in terms of the concept that I'm teaching you, although some people like to say functional notation and some people like to use function notation. But essentially, I'm still going to give you the same kind of concept introduction here. By now, you might have seen some functions, and some functions you might have seen as y equals the function equation. Sometimes you might have also seen it as designated as something that looks like this, which we call f of x. What you need to know is that the letter f, or the whole thing f of x, is the same thing as saying y. The reason why we use functional notation, though, is dependent on the situation in which I'm asking you to find certain things about the function. It's kind of a shortcut, symbol way of me asking you to solve certain things or find certain things about the function. What you need to know is that a function, and I've given you two here as examples, can be designated by a letter. In this case, I've given you a function designated with the letter f, and I've given you another function designated with the letter g. That is the letter that is in front of the brackets here. Inside the brackets is another letter. We call this the variable. It is the variable that our function is using in the equation. So if I see f of x, that tells me that the equation that I would see coming after it would use the variable x. And some functions have more than one variable, and if they do, you would see both variables inside this bracket. And the variables can be any letter. You could see t, you could see z, you could even see y, and these letters can be any letter as well. What's important, though, just for confusion's sake, is don't use the same letter for both. You would have one letter for the function and one letter for the variable. Now, I'm going to show you some examples of why we use functional notation and in what situations you may see it, and actually when it can be useful to you as well. So my first example that I've given you here is a linear function, very basic. F of x is equal to 2x plus 4. Again, you might have already seen something that looks like this, and it might actually be y is equal to 2x plus 4. Again, f of x and y are the same thing. But the reason why we use f of x is, as I've shown you up here, what I could potentially ask you is find f of 4. And what this means is I would like you to replace x the same way I replaced it inside the brackets. I replaced x with 4. I would like you to do the same thing, replacing x with 4 inside the brackets or inside here instead of x. What this also means is, in not so many words, I am asking you to find y when x is equal to 4. That's pretty much what I'm asking you to do, but in a lot less words. And all you have to do here is solve, and very simply you would get that f of 4, or f of x when x is 4, is 12. We could also say y is equal to 12. And what you've done without actually maybe knowing it is you have now officially found a coordinate on this graph or on the plane of this function. The coordinate is when x is 4, y is 12, so our coordinate is 4, 12. On the flip side, on this side here, I have here, instead of asking you, can you find x when y is 3, I am asking you to find f of x equals 3. And in the same kind of respect as the first example I've given you, I'm asking you, can you replace f of x here with 3 and tell me what you get for x? So again, in not so many words, I'm actually asking you to find x when y is equal to 3. Because remember, this is the same thing as y is 3. And so your job is to take the function I've given you at the top of the screen and replace your f of x with 3. And in this case, you're solving an equation that I hope you're comfortable solving at this point of your math careers. And you're just solving for x. And in this case, you would subtract 4 on both sides, divide by 2. You would get negative 1 over 2 is equal to x. So again, what you've done without maybe knowing it is you've now found another coordinate point on this function, which is negative 1 over 2, 3. Talking about finding coordinate points on a Cartesian plane, here is an example that I want to give you where you are actually going to take a new function, which I've given you here, f of x is equal to 3x plus 5. Remember, it's the same thing as this. It's the same thing as y equals 3x plus 5. And in this example here, I am asking you, can you replace x in your original function with 1 and solve for y. And when you do that, in this case, you would just get 8, which is kind of the same thing as y is equal to 8. And so you have found a coordinate here, 1, 8. When x is 1, y is 8. Same thing for the bottom example here, f of 2. Replace your x with 2 and solve to tell me what f of x is or what y is. And when I solve here, I get 11, or y is equal to 11, or f of x is equal to 11, whatever you want. But it's still telling you that you've now found when x is 2, y is 11. Why this is kind of cool is that now you've found 2 points, and using a Cartesian plane, you can graph the linear function. Now, my Cartesian plane is blank right now. I did not put a scale on it, but just so that we can approximate it, we'll pretend that this is like 1, 8 is somewhere here. 1, 8. And then we'll pretend that this is like 2, 11. And now what's super great is that I can draw a straight line through these points, and using the f of x symbols very quickly, I have found 2 coordinates so I can graph my function. My last example for you is we're going to move away from f and x, and I'm going to give you some examples with the letters g, h, t, and z. So on this side here, I have g of t is equal to 4t squared minus 5. I've also moved away from linear functions just to get us a little bit uncomfortable here. And so what I'm asking you to do once again is, can you replace the variable, in this case t, with the number 8? So I would take g of t and I would replace my t with 8, like this. And so very easily you can do this calculation. In this case, you would get 256 minus 5, and you would get that this is equal to 251. So once again, now you know that when x is 8, y is 251. And in the same flip respect, I can solve for t when g of t is 139. So I would do 139 is equal to 4t squared minus 5. Now, because this is a second degree or quadratic, I'm assuming that you would know that you would add 5 onto both sides, and then you would divide by 4 and square root. You would get 144 is equal to 4t squared, and then you would divide both sides by 4. 36 is equal to t squared, so t is equal to 6. So in this example, your coordinate would be 6, 139. On the other side of this page, I've used another different kind of function. In this case, it's called h, and we're using the letter z inside as its variable, and we are replacing, in this case, z with 20. So I would say, I'm just going to write here y, just to give you an example of how you can write this in different ways. Y is equal to 20 minus 4. The square root of 16 is 4. So our coordinate for this one would be 20, 4. And down here, I would replace my h of z or my y with 15. 15 is equal to the square root of z minus 4. And I hope you know that at this point you would actually square both sides to remove the root. And if I do 15 squared, I get 225 is equal to z minus 4. And then I would add 4 onto both sides, and I would get 229 is equal to z. And so now my coordinate point for this last one is 229, 15. I feel like a lot of students get confused in terms of which one is my x and which one is my y, or which one is my first coordinate and which one is my second coordinate. But just understand that your function notation, your h of z, your g of t, is always y. And whatever is inside, whatever variable is inside, is always corresponding to your x-axis. So even if the letter isn't x, this letter here corresponds to your x-axis, your independent variable. I hope this gives you a good guide in terms of when you would see function notation and how useful it can be for you to find certain things about your functions in not so many words. Thanks for listening.